welcome to this second video on the germ theory lesson in the human body part 2 scheme. So in the first part we saw an experiment to do with meat, and if meat is left out and whether it goes bad or not depending on whether there's a lid covering the meat or not. And I think that's a really nice simple illustration of how germs kind of operate. But it didn't prove the decisive evidence. And the reason it didn't prove that is because the supporters of spontaneous generation, they said, well, hang on, so you put that lid on the glass box. I can show you the experiment here. So you put the lid on here, so okay, you stopped what you call germs getting in, but they couldn't even countenance the idea that these tiny little invisible organisms could exist. And actually, when you think about it, that's a really counterintuitive idea. They said, okay, the reason this one didn't go off is nothing to do with these germs, it's not to do with the flies or anything. Actually, it must be to do with the air. Now, actually, there were experiments done at the time which disproved that. They put a kind of net here which air could get through, but flies couldn't, and the meat still didn't go off. But that wasn't enough for the supporters of spontaneous generation. So what we're going to look at in this part of the lesson is the really famous experiments that Pasteur did, and Pasteur actually did do these, it wasn't someone else 300 years before. Pasteur did these experiments to really conclusively show that there were these kind of invisible microorganisms, germs, in the air. I might even call them pathogens here, because that's what we're going to be coming back to again and again and again throughout this scheme of work. That the pathogen is this thing that causes these subsequent processes to happen. So we're going to look at the experiment with the swan neck flask. So what I'm going to do is draw two of these, and I'll explain to the students, and you can do this as well when you're teaching this, exactly what happened. So a swan neck flask is really a kind of S-shaped flask which gets much narrower at the end. And what Pasteur did is he filled two of these with sugar solution. So I'm going to draw one, and then let's draw another one up here like this. So they get kind of narrow at the end like that. And he put sugar solution in each of them. Now, the first thing that he did, and this is quite interesting, just general knowledge I suppose for students, is that he heated them. So that's my attempt at drawing fire, hopefully. You can see that. So he provided heat to them. He increased their thermal energy store. And the reason he did that, and it's really worth explaining this to students, is because he wanted to make sure that the samples were completely identical. And again, that's a really important part of science. He wanted these samples to be identical. It wouldn't be a valid conclusion. He couldn't make valid conclusions if they were different. So he heated them both. They were identical volumes, even if my diagram doesn't suggest it. Everything else was the same, and they were heated. And the reason he did that was to make sure there were no germs present before the experiment started, or no pathogens present, we might say. And what's interesting here is, students will enjoy this, I'm sure, this is an example of pasteurization. And we still talk about pasteurized milk and beer and so on, and that's named after Pasteur. Yeah, it's worth drawing students' attention. That's where that word comes from. So we heated them up to kill the germs, kill the pathogens, and make sure that everything was exactly the same before the experiment. And then in the next part of the experiment, he did the following. So we can go down here. Now in one of these flasks, he broke the glass that formed the neck of the swan neck flask. So he got rid of that and chucked it away. So he left the flask open like this. But in the other flask, he left it completely intact. And I can see already my drawings are all different shapes and sizes, and it would be worth you thinking about how you could avoid doing that when you're drawing it. I'm not sure what the best way is. But anyway, we'll carry on for now. So what we've got is these sugar solutions in both of them. Now, again, the science of this is maybe going a bit beyond what students will be comfortable with, but we should be able to illustrate it fairly clearly, because this is taught at the start of year 8. We're going to talk about fermentation. I think maybe you don't want to get into the weeds with that. I think effectively we can say the people who believed in spontaneous generation, they thought that if oxygen could get into the sugar solution, then it would ferment. And you can really say fermenting is a bit like going bad, so it kind of goes sour or something like that. And we can pretty much leave it there. So let's show what the advocates of spontaneous generation thought. What did they expect to happen in this case? So let's draw this one here. So this one, in fact, let's draw both of them together. So in this flask, I'm going to draw oxygen in green here. I'm sorry, that's not clear. So let's draw it like this. If spontaneous generation was true, well look, oxygen would be able to get into this one. Let's put that O2. And it would also be able to get into this one. I'll just draw my sugar solution in there, so let's add that in there, like that. O2 would also be able to get into there. So if spontaneous generation was true, and oxygen was the thing that was causing the fermentation, well, we'd expect both of them to start fermenting. I'm just going to draw that. Really matter too much, we might show colour change, or maybe it's getting kind of cloudy or something like that. But we can say something would happen in both cases. Whereas what Pasteur predicted was, and this is why he did the experiment, that in the open flask, something different would happen to what would happen in the closed flask. So let's draw our unbroken swan neck flask like this. Because what Pasteur said was, okay, fine, oxygen can get into both. Let's put O2 and O2 into here. Draw the sugar solution again. But what's different about these is that in the open flask, these bigger particles, so these germs, they could also get in. Whereas in this case, the germs, they would get to here and they'd get kind of stuck and they weren't able to get in. And he said, because in this case the germs could get in, or the pathogens as we should probably call them, they could get into this solution where the neck is broken, but they couldn't get into this solution where the neck is not broken. Well, what we'd expect to happen is this one should start to ferment. So maybe it gives off the gas, might go a bit cloudy, and this one should just stay as it is. And again, just like before, you could add a kind of 1 or 2 to your diagram and ask students to show you on their fingers, 1 or 2, which one actually happened, what do you think Pasteur actually observed. And of course, what Pasteur actually observed is that this was what happened. So the people who had believed in spontaneous generation, their prediction did not come true. Their guess, the deductions that came from that, did not agree with the experiment. Therefore, their guess was wrong. Whereas Pasteur, his guess that disease was spread by these germs that get from outside in, that agreed with what was the deductions from that guess agreed with what was observed in the experiment, and therefore scientists believe that that guess was true. So that's another really nice illustration of why the germ theory of disease, or the evidence that supports the germ theory of disease. And just to finish off this video, the reason we do all this, which seems a little bit obscure, and, you know, apart from the fact that it's good general knowledge, you might say, well, okay, why are we teaching this? But the one big idea that we want to get across to students throughout this series of lessons on disease is that what causes disease is pathogens from the outside getting in, whether it's being bitten by a mosquito, whether it's someone sneezes on you, whether it's you eat a dodgy piece of meat and bacteria get in, whatever. That's how it happens. Because then we can also start to understand all of our body's defenses, whether it's the kind of outer physical defenses, whether it's the immune system that we have, where, you know, how vaccines work, how herd immunity works. All of it comes back to this one idea that pathogens are what cause diseases. Obviously, in this case, I'm talking about communicable diseases. We'll come back to the other categories of diseases later. But this lesson really wants to introduce that core idea that will then embed throughout this the first part of this scheme of work. So I hope that's been useful, and there will be more videos on this scheme of work to follow. Thank you.